electron hole pairs are created, generated, under which bias mode LED operates. The representation symbol of a solar cell, photoelectric effect, photocells, where we are using light emitting diode. Now they are not called holes or electrons specifically, they are charge carriers. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. In my today's session on semiconductors, we will understand the working of two semiconductor devices. One, an interesting device called light emitting diode, and the next one what we call as solar cell. Before we creep into these devices, let us recall what we did in our previous session, where we understood the phenomenon of rectification, where I told it is a process of converting an AC signal into a DC signal. And a device which performs this operation, like the PN junction diode, we call them to be rectifiers. And we studied two types of rectifications. One is called half-wave rectification, and the other one is called full wave rectification. In a half-wave rectifier, I used a single diode. Therefore, only positive half cycle was rectified. In a full wave rectifier, I used two diodes. Therefore, both the half cycle as well as the negative half cycle was rectified, and we also studied the waveforms. And we understood a special type of diode called Zener diode, which operated only when it was reverse biased. Now students, we start understanding something called as a light emitting diode, whose applications is always asked for 2 marks in the examination. Light emitting diode, ಬೆಳಕನ್ನು ಹೊರಸೂಸುವ diode, light emitter. So in short, we call it as LED, light emitting diode. So this is the symbol of a light emitting diode. P-type material, N-type material, And very clearly you can see light is emitted by this diode. Therefore, it is called light emitting diode or LED. Now, it is a diode LED or light emitting diode is a diode which converts electrical energy into light energy. The first one you should know is it will convert electrical energy into light energy only when it is forward biased. For 1 mark, you may get this question: under which bias mode LED operates? LED, light emitting diode, operates when it is forward biased. ನೆನಪಿದೆ ಅಲ್ವಾ? P-type material ನ ಪಾಸಿಟಿವ್ ಆಫ್ ದಿ ಬ್ಯಾಟರಿ ಕನೆಕ್ಟ್ ಮಾಡೋದು, N-type material ನ ನೆಗೆಟಿವ್ ಆಫ್ ದಿ ಬ್ಯಾಟರಿ ಕನೆಕ್ಟ್ ಮಾಡೋದು, ಅದನ್ನೇ ಫಾರ್ವರ್ಡ್ ಬಯಾಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. So please do keep in mind, a light emitting diode, the so-called LED, operates only when it is forward biased. It converts electrical energy into light energy when it is forward biased. Now, when LED is forward biased, both the majority charge carriers move towards the junction and they recombine. Andre, so this is the junction. So we have the P-type material, N-type material, holes, and here electrons. Whenever the LED is forward bias, holes and electrons move towards the depletion region. They recombine. Now they are not specifically called as holes. They are not specifically called as electrons. After recombination, they are called by the word charge carriers. Mobile charge carriers. Now, the depletion region slowly goes on decreasing. The width of the barrier decreases. For one particular potential breaks down, conduction happens, and electrical energy is now coming as visible light. And this is how an LED performs. So what happens, students? When the LED is forward biased, under the forward biased mode, what is happening? The holes as well as the electrons, which are the majority charge carriers, they start moving towards that depletion region, potential barrier, forbidden region, and they recombine. Now, this combination of holes and electrons we call as charge carriers. So what are these charge carriers doing? They will break the width of this depletion region. They will reduce the potential barrier. And for one particular bias voltage, conduction happens. And that electrical energy is given out as visible light. So beautifully, when LED is forward biased, electrical energy is converted as light energy. Now, when we come to the typical uses of LED, very much, as I told, important as a 2-mark question. The first use of light emitting diode, LED, is it is used in TV remote sensors. The television remote sensors operate by using light emitting diode. It is used in burglar alarms. Burglar alarms andre thief alarms anta artha. And very interesting, this burglar's alarm will work on the principle of photoelectric effect, photo cells, where we are using light emitting diode. LED is used in calculators, the 7-segment calculators, we use LED. It is used in traffic signals, and finally for optical communication. So these are the uses of LED. First, used in TV remotes. Second, burglar alarms, which works using photocells, principle of photoelectric effect. Used in calculators, 7-segment displays. Used in traffic signals. And finally, used in optical communication. Now, the next one, what we study is something called as a solar cell. We will now understand the principle of a solar cell, the representation symbol of a solar cell, working of a solar cell, and its applications. A solar cell is a device which converts solar energy into electrical energy. LED ಏನ್ ಮಾಡ್ತಿತ್ತು? ಎಲೆಕ್ಟ್ರಿಕಲ್ ಎನರ್ಜಿನ ವಿಸಿಬಲ್ ಲೈಟ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡ್ತಿತ್ತು. ಸೋಲಾರ್ ಸೆಲ್ ಏನ್ ಮಾಡುತ್ತೆ? ಸೋಲಾರ್ ಎನರ್ಜಿನ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಎನರ್ಜಿ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡುತ್ತೆ. And this is the typical symbol of a solar cell. Light is falling on the cell, which will be converted as electrical energy. This is the working of a solar cell. P-type holes, N-type electrons. Now if you observe, both of them are connected to a load resistor, and here is an ammeter that will measure the current generated. ಗಮನಿಸಿ ಸರ್ಕ್ಯೂಟ್ ಅನ್ನ. ಪಿ ಟೈಪ್ ಮೆಟೀರಿಯಲ್ ಇದೆ, ಹೋಲ್ಸ್ ಪ್ರಾಮಿನೆಂಟ್ ಆಗಿರುತ್ತೆ. ಎನ್ ಟೈಪ್ ಮೆಟೀರಿಯಲ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಪ್ರಾಮಿನೆಂಟ್ ಆಗಿರುತ್ತೆ. ಡಿಪ್ಲೀಷನ್ ರೀಜನ್ ಇದೆ. ಎಕ್ಸ್ಟರ್ನಲಿ ಲೋಡ್ ರೆಸಿಸ್ಟರ್ ಅನ್ನು ಕನೆಕ್ಟ್ ಮಾಡಿರ್ತೀವಿ. ಮತ್ತೊಂದು ಆಮೀಟರ್ ಅನ್ನ ಕರೆಂಟ್ ಕಾನ್ಸ್ಟಿಟ್ಯೂಟ್ ಆಗುತ್ತಲ್ವಾ, ಅದನ್ನ ಮೆಜರ್ ಮಾಡ್ಲಿಕ್ಕೆ ಉಪಯೋಗಿಸ್ಕೊಂಡಿರ್ತೀವಿ. Now, when radiations of suitable energy falls on the diode, light, radiation andrenu, light. When radiation of suitable energy falls on the diode, again electron hole pairs are generated. So when radiation falls on the diode, electron hole pairs are created, generated. Charge carrier gal generate ಆಗುತ್ತೆ. Exactly as we saw before, the generated electrons move towards the p side and holes moves towards the n side. Mat puna recombine ಆಗುತ್ತೆ. There is recombination of holes and electrons. Now they are not called holes or electrons specifically. They are charge carriers. They will be collected at the two metal contacts and a potential difference is developed. Because of the flow of these charge carriers, recombination, a current is constituted which is called photocurrent. So exactly as your photoelectric effect, light is converted into photocurrent. So ಏನಾಗತ್ತಿಲ್ಲಿ? Light of suitable energy falls on the diode. Now the holes start moving towards n-type. Electrons start moving towards p-type. Recombination of holes and electrons. Electron hole pair create ಆಗುತ್ತೆ. Charge carriers create ಆಗುತ್ತೆ. Depletion region breaks down. Due to the flow of these charge carriers, there is a certain potential difference developed. The moment you say potential difference, there is current called photocurrent, and the strength of this current is measured by the ammeter. And this is the graph which will actually show the working of a solar cell. Uses of solar cells. It is used in artificial satellites. especially where we have remote sensing and communication satellites, solar cells are used. Space vehicles, astronaut vehicles, used in calculators, remote radio and telephones, storage batteries, and so on, exactly like an LED. So in my today's class, we have understood the working of a light emitting diode and a solar cell. Next, I'll take up a very interesting topic called digital electronics. Until then, have a nice time. Thank you.